Imagine you're a health planner in rural India. You need to refer a patient for cardiac surgery. You pull up the directory and find a hospital that lists cardiology, neurology, 14 different specialties. Sounds great, except it has two doctors. Now, this is not hypothetical. This is a real facility in this data set. We ran all 10,000 facilities through a deterministic trust engine, and here's what we found. 2,300 of these have specialties that their staffing cannot support. 126 report zero doctors, 95% without accreditation, so on and so forth. Now, let's dig into one of these facilities, Shaurya Hospital. When you look at it, on the face of it, seems okay in that it shows a 72 out of 100 score, which is moderate trust. But this is also the drawback of a single number in that it hides some of the details. So, for example, if you look at staffing adequacy here, you will see there's two doctors covering 14 specialties, which means 1:7 ratio, which is something to be flagged. And if you look at the flags here, this fact is explicitly flagged in red here. We actually go through each of the claims specialties here and verify against data in our dataset to either validate or invalidate these claims. As a planner, I can now go download this report with a single click of a button and use this for accreditation and other use cases. Now, let's switch to look at the architecture a little bit. Our design is split into two basic components. The LLM reads language, the engine decides trust. These two are never mixed. LLM passes messy specialty names, interprets your search. It never scores or ranks trust. That's all deterministic. So let me take you to a live engine demo. And let's say I click on this one here. This is live. And if you see this, this is 80 on 100, but even this gets flagged because some of these claims do not have matching data in the data set, right? So the engine doesn't give anyone a free pass. And when data is missing for a dimension, the engine doesn't just guess or penalize. It marks it insufficient data and normalizes the score across the data that is available. So we rely on honest math and not fake confidence. Now, let's go back here and let me show you how natural language search works. So, a planner comes in and says, I want to look at all hospitals in Kerala with cardiology. Then the planner clicks in here, for example, and then they review this profile and note down their decision. This is kind of a workflow where it is an audited, saved workflow. So, for example, here I can go and say staffing issue, tag it to a specific dimension, say staffing adequacy, and then defer the decision, right? And this is saved in Lakebase and creates the audit trail that the planner can use later, right? So everything runs on Databricks end to end, Unity catalog tables with live raw cons, facilities, pin codes, etc., full data lineage, full provenance. Now, just to round it out, there are 10,000 facilities, seven trust dimensions, but zero hallucination. You ask any chatbot, you will get a confident paragraph that you cannot verify. You ask Trust Desk, you will get a score you can trace, evidence you can check, and uncertainty that you can trust.